Find the damped displacement in inches. In this problem, a machine oscillates in a vertical direction at 180 cycles per minute. The natural frequency of vibration is 200 cycles per minute. Currently, the machine is supported by a spring which provides no damping, resulting in a displacement of 1.042 inches. This displacement of 1.042 inches will be referred to as U sub s and refers to the amplitude of the undamped oscillation. The spring is replaced by a damper which has a damping ratio of 0.25 and an unknown displacement. When replaced by the damper, the system continues to oscillate at 180 cycles per minute. The damped displacement, U sub d, equals the damped deformation response factor, R sub d, times the static displacement, U sub st. We'll first solve for the damped deformation response factor, R sub dd, which is a function of the circular frequency, the natural circular frequency, and the damping ratio. The problem statement provides the damping ratio is 0.25. The circular frequency terms can be calculated from the frequency terms, f and f sub n. And after multiplying by a conversion constant, the circular frequency equals 18.85 radians per second, and the natural circular frequency equals 20.94 radians per second. With these three variables plugged in, the damped deformation response factor equals 2.047. The second variable we need to calculate is the static displacement, U sub st. To find the static displacement, we'll equate the undamped displacement, U sub s, to the undamped deformation response factor times the static displacement. And we'll solve this equation for the static displacement. The undamped displacement, U sub s, is the displacement that occurs when the machine is supported by the spring, and equals 1.042 inches. The undamped deformation response factor can be calculated as before, except this time the damping ratio equals 0. So the equation simplifies to 1 divided by the quantity, 1 minus the circular frequency divided by the natural circular frequency squared. Plugging in the values for omega and omega sub n, the undamped deformation response factor equals 5.273. Therefore, the value of the static displacement calculates to 0.198 inches. Plugging 0.198 inches into our equation for the damped displacement, we find the damped displacement equals 0.405 inches. When reviewing the possible solutions, the answer is D.